to True Projects. In this video, we are going to explain about the project, which is a stable AI-based binary and multiple class heart disease prediction model for IoMT. Introduction. Heart disease poses a significant threat to human life. With high morbidity and mortality rates, early prevention, detection and treatment are essential to mitigate its impacts. Current prediction models often fall short, primarily providing a binary diagnosis, leaving out crucial information about the severity of the condition. This project aims to bridge this gap by simultaneously predicting both binary and multiple classes of the heart disease, providing a more detailed assessment. This project focuses on developing a robust and versatile artificial intelligence-based prediction model for heart disease within the context of the Internet of Medical Things. It addresses the critical need for accurate and comprehensive heart disease prediction, monitoring and diagnosis. The project leverages the power of Internet of Medical Things, which involves the interconnectedness of medical devices and systems. By integrating AI into IoMT, the project aims to provide a scalable and technology-driven solutions for heart disease monitoring and diagnosis. This not only enhances the accuracy of predictions, but also facilitates remote monitoring and early intervention, potentially saving lives and reducing healthcare costs. Objective. The primary aim is to create a precise and versatile heart disease prediction model that is capable of providing both binary and multiple class classifications. We aim to employ a variety of machine learning algorithms encompassing SVM, random forest, decision tree, logistic regression, k-nearest neighbor, XGBoost, GNB, GBTT, as well as ensemble techniques such as bagging and incorporate fuzzy logic. These help in elevating prediction accuracy, managing intricate data relationships, and counteract overfitting to amplify the dependability of predictions, simultaneously determining the presence of the disease and its security levels. Ultimately, objective is to enhance the early detection process, tailor treatment strategies more precisely, and enable remote patient monitoring for heart disease with the overarching goal of reducing the healthcare burden and augmenting patient well-being. For implementing this project, we need hardware and software requirements. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. In software requirements, we need Anaconda 3 and Visual Studio Community version. For implementing this project, we have designed few modules in the flow of work. The first one is importing the packages. This module involves importing the necessary Python libraries and packages required for the project's execution. NumPy is imported for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib for visualizations, Seaborn also for visualizations, Scikit-learn for machine learning. Exploring the dataset. This step involves loading and examining the heart disease UCI dataset, gaining insights into its structure, attributes, and the nature of data it contains. Data processing. This module involves two key steps, which are dropping the unwanted columns using Pandas data frame, removing irrelevant or redundant data columns from the dataset to streamline further analysis. Dropping the null rows using .drop function, eliminating rows with missing or incomplete data to ensure the data's integrity. Visualization using Seaborn and Matplotlib. This step involves creating data visualizations using the Seaborn and Matplotlib libraries to better understanding of the data distributions, relationships, and the patterns. Label encoding and feature selection. This module encompasses of label encoding, converting categorical variables, categorical data into numerical format, making it compatible with machine learning algorithms, and the other one is feature selection, identifying and choosing the most relevant data attributes that significantly contribute to the prediction model's accuracy. Building the model. In this phase, a variety of machine learning algorithms are employed to construct the prediction model. This includes SVM, which is support vector machine. It is a supervised machine learning algorithm used for classification and regression tasks. It finds a hyperplane that best separates data points into different classes while maximizing the margin between them. It is used in this project for its ability to classify patients into different heart disease risk categories based on their health data. It is effective in handling both linear and non-linear relationships in the data. Random forest. Random forest is an ensemble learning method that combines multiple decision trees to make predictions. It aggregates the results of individual trees to improve prediction accuracy and reduce overfitting. It is employed to enhance the prediction accuracy of heart disease by reducing the variance associated with single decision trees. It is particularly useful when dealing with the complex and high dimensional data. DT, which is decision tree. Decision tree is a tree-like model that represents decisions and their consequences. It recursively splits data into subsets based on the most significant attribute, ultimately leading to a decision or classification. It is used for its interpretability, helping to identify key features in the heart disease prediction. It provides insights into which factors contribute most to the diagnosis. LR, which is logistic regression. It is a statistical method used for binary classification. It models the probability of an instance belonging to a particular class based on linear combination of input features. It is employed to determine the likelihood of a patient having heart disease or not. It is simple yet efficient choice for binary classification tasks. KNN, which is K nearest neighbor. It is a lazy learning algorithm that classifies instance based on the majority class among the K nearest neighbor in the feature space. It is used to identify patterns in the heart disease dataset by considering the proximity of similar cases. It is particularly effective when dealing with local data clusters. XGBoost, Extreme Gradient Boosting. It is an optimized gradient boosting algorithm known for its speed and performance. It builds an ensemble of decision trees to improve prediction accuracy. It is employed to boost the performance of heart disease prediction model. Its boosting technique helps in correcting the errors from previous models, leading to enhanced accuracy. Gaussian Naive Bayes. Gaussian naive Bayes is a probabilistic algorithm used for classification. It assumes that features are normally distributed and independent of each other. It is chosen for its simplicity and efficiency in classifying patients into heart disease categories, assuming that the features allow Gaussian distribution. Voting classifier. It is an ensemble method that combines the predictions of multiple Bayes classifiers. It is used as a majority vote or weighted vote to make a final prediction. The voting classifier combines the outputs of various machine learning algorithms to improve overall prediction accuracy in the project. GBDT, which is Gradient Boosting Decision Tree. It is an ensemble learning method that builds decision trees sequentially, each correcting the errors of the previous one. It is used to capture complex relationships in the heart disease data and enhance the model accuracy through iterative correction of errors. Bagging with GBDT, which is Bagging with Gradient Boosting Decision Tree. This combines bagging ensemble method with GBDT to improve model stability and generalization. This trends off both techniques to create a more robust and reliable heart disease prediction model. Fuzzy GBDT, which is Fuzzy Logic with Gradient Boosting Decision Tree. This integrates fuzzy logic with GBDT to reduce data complexity and enhance model adaptability. This algorithm is chosen to handle data with varying degrees of uncertainty and fuzziness, making the model more flexible and adaptable. Bagging with fuzzy with GBDT, which is bagging with fuzzy logic and gradient boosting decision tree. This combines ensemble methods, fuzzy logic and GBDT to create a versatile and robust heart disease prediction model. It leverages the advantages of ensemble methods and fuzzy logic to handle complex heart disease data and enhance prediction accuracy. Training the model. This step involves feeding the pre-processed dataset into the selected machine learning algorithms for training. The algorithms learn from the data patterns and relationships to make accurate predictions. Flask framework with SQLite for sign-up and sign-in. This module involves setting up a web application using the Flask framework with an SQLite database for user registration and authentication. User gives input as a feature values. User provide input by entering feature values relevant to their health status or medical history. The given input is pre-processed for the prediction. The user provide input is pre-processed to ensure it aligns with the model's requirements, including data formatting and encoding. Train model is used for prediction. The trained machine learning model is employed to make predictions based on the pre-processed user input, providing insights into the user's heart disease status or severity. Final outcome is displayed through frontend. The project's front-end interface presents the prediction outcomes to the user, indicating whether they are at risk of heart disease and, if applicable, the severity level of their condition will be mentioned. This is the comparison graph of the project, where x-axis represents the accuracy score and y-axis represents the algorithm names. And here we are using the voting classifier for the prediction purpose in the interface because it is performing well. For execution of the project, first we need to open the code folder which contains the source code files. This is the code folder and this is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file. This file contains the algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the signup file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So we will copy this address and then paste it in Anaconda prompt. So now we will open the Anaconda prompt. Using the cd command followed by the space, we will paste the copied path. Now we will click on enter. This command used to change the current directory to the code folder's path. So here we will type python space app.py. This will compile app.py file and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost, and the port number unless configured differently. So this is the localhost and this is the port number. Now we have to copy this local link provided by the framework and paste it in any browser. So I prefer Google Chrome. I will paste it in that. So here we will paste the link and then click on enter. So here we can see that it has redirected to the homepage of the project which is displayed in the browser. And this front end is built by using the Flask framework. Now we will click on sign up. We have to fill all the registration details if we are registering newly. I have already registered, so I'll directly click on sign in. I have to provide my credentials for logging in. Now I'll click on sign in. So here we can see that some parameters where we have to fill all these medical parameters. By filling all these medical parameters, we will get the heart disease prediction whether the person has the heart disease or not. If he has the heart disease, then he will be predicted of which stage he is. So now we will fill these details. So the age of the person is 63 and the gender is male and the dataset type is Cleveland and the chest pain is typical angina and the blood pressure is 145 and the cholesterol level is 233 and the fasting blood sugar is true and the electrocardiographic results are left ventricular hypertrophy and the maximum heart rate achieved is 150 and the exercise induced angina is false and the old peak value is 2.3 and the peak exercise ST segment is downsloping. Now we will click on predict. So based on the given input, it is predicted that the patient has no heart disease. Now we will give other patient details. Age is 67 and the gender is male and the dataset type is Cleveland, and the chest pain is asymptomatic, and the blood pressure is 120, and the cholesterol level is 229, and the fasting blood sugar is false, and the resting electrocardiographic results are left ventricular hypertrophy, and the maximum heart rate is 129, and the exercise induced in angina is true, and the old peak value is 2.6, and the peak exercise ST segment is flat. Now we will click on submit. So it is predicted that based on the input, the patient is predicted with stage 1 heart disease, which means he has the heart disease but he is in the stage 1. Now we will give one more person details. So the age is 56, and the gender is male. Dataset type is Cleveland, and the chest pain is non-anginal pain. Resting blood pressure is 130, and the cholesterol value is 256, and the blood sugar is true. Electrocardiographic signals are this one, and the maximum heart rate is 142, and the exercise induced angina is true, and the old peak value is 0.6, and the exercise ST segment is flat. Now we will click on submit. So it is predicted that the patient is predicted with stage 2 heart disease. Now we will give one more patient details. I entered all the details of the other patient. Now we will click on predict. So based on the given input, the patient is predicted with the stage 3. Now we will give one more patient details. I entered the details of the other patient. So now we will click on submit. So based on the given input, it is predicted that the patient is suffering with the stage 4 heart disease. In this way, we can give the patient related medical parameter details, and for that we will get the prediction whether the person has the heart disease or not. If he has the heart disease, we will get at which stage he is. Now we will log out. Conclusion of the project is, the project has successfully developed a sophisticated AI-based prediction model that excels in both primary, binary and multiple class classification of heart disease. This achievement marks a significant advancement in accurately diagnosing and assessing the severity of heart conditions. By leveraging a diverse set of machine learning algorithms including SVM, random forest, decision tree, logistic regression, KNN, XGBoost, GNB, GBT, and ensemble methods, the project has demonstrated the power of algorithmic diversity in improving prediction accuracy and robustness. The integration of the model with the IoMT has paved the way for remote patient monitoring and early intervention. It holds the potential to transform how healthcare providers approach heart disease management, making it more patient-centric, efficient, and accessible. The project results have significant implications for the healthcare sector, offering the promise of early diagnosis detection, tailored treatment plans, and ultimately reducing the burden of the heart disease on the healthcare systems. It underscores the potential of AI and IoMT technologies to revolutionize healthcare practices and improve patient outcomes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.